you know, map skills are kind of a difficult skill to use, and the landscape changes so rapidly that by the time a map is produced, you know, buildings are built, landscapes are changed. It changes so quickly, and so global positioning systems allow you to navigate from one point to another point and be able to document locations very quickly and easily. And how that's done is through the use of a set of satellites that's in stationary orbit around the Earth. Not sure how many there are right now. Just a few years ago there were 24 that were usable. 24 stationary orbit satellites, and what that means is that those satellites, as the Earth rotates, those satellites are in a fixed position and rotate along with the Earth. And so those satellites are in the same relative position from the Earth, and they also maintain relative position to each other. You can kind of basically think of these as receivers, because they pick up a signal from those satellites. And if you go ahead and hit that top button there, you can turn it on. You have yours on yet? All right. This button on the side here is the page button, so you can use that to kind of page through different screens on this. You have a map page, a trip computer, and then a main menu. When you get to main menu, stay there. Okay, this right here, this button here in the middle is basically a joystick, and so you can move it up and down and side to side. Go ahead and scroll down to where you see satellite and highlight satellite. And once you get there, click down on the joystick, and you'll get a page like this. That basically shows you the relative strength of the satellite signals. To get a good fixed position, you need a minimum of 3. You have to receive satellites from at least 3. You have to receive signal from at least 3 satellites. And so that shows you, right now I show getting pretty good signal. Now, something about this, heavy forest cover and also buildings will impede that signal, will interfere with that signal. And so I've been in some pretty heavy forests before where, you know, try to get a coordinate and it won't work very well. And so it does require that you're in somewhat open conditions. Now, a few years ago, prior to 2002, the Department of Defense had actually an error into the signal, and so you could get within basically what amounted to football distance from where it was you wanted to go, from a coordinate. And so that could be in any direction, basically 100 meters. Well, after 2002, they removed that error as this device became more and more useful in non-military operations. And so now with even a simple unit like this, you can buy GPU within 4 or 5 meters or 15 coordinate. And so what you can use this for then, and do any of you have GPS units in your car? It's becoming more and more, I don't either, you know, but it's become more and more common to use GPS coordinates or GPS units in your cars that basically you program in where you want to go, and this those units that you have do not have built-in maps. This one does. And what you can do is, in fact, we'll collect a waypoint right here. You need to hold it out away from yourself to get the best signal, because even if you're standing over it, it can prevent the signal. And so press and hold the joystick, until a screen pops up. It says mark waypoint. Click down on that, and it should say 14. And then if you hit OK, which go ahead and do that, hit OK, that records a waypoint. And all that is that's the coordinates of this spot right here. Now, once you, and you can actually put in upload coordinates from a computer off of another map, and you can upload them into this unit and then use this to navigate to those points. And so this is how you would do this. Let's go ahead and walk out here a ways. Waypoint that you just collected, and then you'll see it says go to. Go ahead and click that, and then you'll come to a navigation page. Does everybody see that? And I'll make sure that in the later class everybody has a chance to go through this. Like I said, this is a brief introduction. So you'll see what looks like a compass right there. This is not like a regular compass. In other words, it won't always face north. In fact, this doesn't work very well. You hold it out in front of you, and as you walk around, you'll see that the compass will turn around to point to the waypoint 14. Okay, so you can go ahead and do that, move around a little bit, because it won't work if you're just standing in one spot. And move around, and you'll see that it stays pointed to that. And so then how you use this, and you'll see at the top it says, it should say on yours the distance. How far away you are in meters. So what you can do is use that then, follow the compass. See, mine's pointing right back to there. So go ahead and follow it. Go ahead. And as you get close to that, it'll tell you arriving at 14. Okay. Chance to work with it.
Oh, you have to hold the button?
No, you have to hold it out in front of you like this. Let's see here. Oh, let's see here. Oh, this one's set to
the point only.
Yeah.
Okay,
And so then once you get there, it tells you you're arriving to that location. And this, like I said, this will get you within 15 to 20 feet. Well, next week when we have our contest, you'll use this and you'll take turns. And I have some checkpoints set up on campus, and it'll basically be a race between groups to see who can get to the checkpoints and find out what's there first, and then back to me. And so we'll have a contest, and also talk to you. Anybody have the time right now? 11:48. Just to say a little bit about how it works. It receives the signal from the satellites, and it uses what's called triangulation. And it goes back to the use of triangulation in using a compass and a map as well. Has anybody ever used a compass and a map? Okay. You know, you can shoot what's called an azimuth to something in the landscape. Let's say you don't know where you're at, but you know you're someplace on this map that you're looking at, and you can recognize a water tower off in the distance, and you can recognize maybe a hilltop. And you know, okay, well, here's this water tower on the map, and here's this hilltop, but you still don't know where you are. What you can do is use a compass, and you get your direction, your compass direction to the water tower, And so now you have a straight line that you can draw in that direction on the compass, or on the map using the compass. So all you have now is a straight line, and you know you're in somewhere along that line, but you still don't know how close or how far away you are from the water tower. Then you can shoot an azimuth and get your direction from the hilltop and draw a line. And then, do you think after you do that, do you think you'd have an idea about where your lines that you drew on the map come together? That's where you are, and so that's called triangulation, because basically you formed a triangle between two objects or landscape features and yourself, and you're able to pinpoint yourself then on the map. Well, basically, satellite, the GPS system works the same way in contest at the beginning of class next week. So if you want to look at these after class, that's fine. Check them out a little bit more. If not, you're free to go for the day. Check it out.
I guess it just says that I was here at those times.
Okay. Is that all you need? Yeah. All right. Super.
We'll be using the destination and the distance.
The air conditioning unit's coming on.
Yeah.
Okay.
Is that how you want this on?
Okay, I'll show you here. So this button right here, that's the page button. And see, that just goes through the different screens,
Okay, yeah.
like that.
Yeah, the main menu. Find and go. Which one will we be using? Find and go?
Okay, but that is just like a joystick. You can move it that way, kind